Hello, and welcome to our third section in this unit, biconditional statements. So go ahead and pause the video, grab this as well as the title, and let's get going. What is a biconditional statement? Well, the prefix bi means two. Okay, so when you see that, anytime you see that prefix, you should think of the number two. So, a biconditional statement sounds like two conditional statements, and that's pretty much what it is. A biconditional statement is equivalent to two statements in one. It is a statement to a conditional statement, or equivalent to a conditional statement and its converse. So if you recall, a conditional statement is just P, a P then Q, the converse is Q then P, so we switch the order. We use specific phrasing, in quotes, if and only if. So we are merging two different statements in one. P and Q, P then Q, and Q then P becomes one statement. And biconditional statements has its own symbol. Now, if you recall, a conditional statement, and I'm going to do this in pink, don't copy this down. A conditional statement is P and then the arrow towards Q. The converse is Q, the arrow towards P. And then a biconditional statement, this is the one I do want you to write down. I'm going to put these down here or to the left for now. A biconditional statement uses a double arrow, kind of like a line. P, arrow, arrow, Q. Okay? And that what this means is P, if and only if, Q, or you could even see you might see it as this P if double F Q. So you might see it that way as well. So those are the notations. Those are the notations for if and only if in biconditional statements. All right, so let's get into an example. Now, the biconditional statement does not necessarily have to be true, and you'll see what I mean in a second. So for example, if, for instance, two angles are complementary, if and only if there's your phrasing, the sum of their angles is 90 degrees. Okay? Now, notice that the if then statement isn't here anymore. It's summed up as the if and only if. Okay? And that's okay, because it covers both bases. Now, you could break this up into two conditional statement. You could say P implies Q by saying if two angles. You could call this part P. You could call this part Q. Okay, and if we break this up into a traditional conditional statement, it would say if two angles are complementary, then the sum of their angles is 90 degrees. Now, if we really look at the statement, yes, this is true. Two angles are complementary, then the sum of their angles is 90 degrees. This is a true statement. Okay? And if we reverse this, if we do Q implies P, or if Q then P, the converse, we could reverse it and say if the sum of two angles is 90 degrees, then the angles are complementary. Okay? And this is also true. So if you notice, this is true both ways. If P then Q and if Q then P, the converse and the conditional are both true. So this is a true biconditional statement. Okay? And let's do this in blue just because that's how we kind of piece this together. All right. So let's show you one where it's actually false. Just really, really quickly. Second example. Let's say we have a statement. If x is equal to 5, x is equal to 5, I should say, x is equal to 5 if and only if x squared is equal to 25. Okay? Now, if we break this apart, we could say P implies Q. If x is equal to 5, then x squared is equal to 25. Okay? And that's true. If x is equal to 5, then x squared is equal to 25. But the converse, if Q then P, would be the flip version of this. If x squared is equal to 25, then x is equal to 5. This is false, because we know that that is not the only answer. We could say a counterexample is equal to x is equal to negative 5. Keep this true. If you square this, it becomes 25, but then x not equal to 5. Okay? Now, biconditional statements do not have to be true. So in this particular case, this is a false biconditional statement. Oops. False biconditional. Okay? So it doesn't have to be true. It's just the way you write it. And we use the special symbols for the double arrow for if and only if. You write if and only if, or you write the double IFF. Okay? If you do have any questions, please let me know. And I will see you in the next one. Bye.